In the dense hedgerows of Normandy, during the heavy rains of mid-July 1944, a camouflaged German anti-tank crew waited for the familiar grind of steel treads, required heavy lift cranes, a secure railhead, and a specialized industrial facility to restore. The front line was universally understood to be a place of destruction, or an anti-tank mine had completely obliterated the transmission and final drive. The company mechanics did not waste a single minute trying to force a fix. They did not have the overhead cranes or the heavy welding equipment required to repair structural industrial trauma. Instead, they verified the tank was clear of the road, retrieved any sensitive equipment, and called for the heavy wreckers. The vehicle was officially pushed out of the second echelon. It was time for the factory to take over. But if the broken tank could not be shipped across the ocean to Detroit, and the local mechanics could not fix it with hand tools, where was this factory located? To understand how the Americans managed heavy industrial labor in a shifting war zone, we have to follow the tow cables back to the heavy recovery crews of the third and fourth echelons. When a Sherman was too crippled for the forward mechanics to save, the battlefield scavengers arrived. An armored recovery vehicle, itself built on a modified tank chassis, would grind its way up to the wreck. Its crew did not carry tool rolls. They carried heavy steel cables and a 60,000-pound capacity winch, not creation. For the Axis forces, a shattered tank meant a long train ride back to a factory deep within the Reich, where civilian engineers, they hooked into the dead Sherman and dragged it backward, away from the artillery zone, leaving a deep furrow of mud in their wake. They towed the 30-ton casualty a few miles behind the front lines, turning off the main supply route into a seemingly ordinary French pasture, or a dense patch of woods. But this clearing was not an empty field. It was a fully functioning, mobile industrial facility. This was the domain of the third and fourth echelons, the ordnance, medium, and heavy maintenance companies. Beneath acres of camouflage netting, the Americans had assembled a factory that ran on diesel fuel and generator power. There were no concrete floors or steel overhead gantries. The mechanics worked in the mud, wearing grease-soaked coveralls, illuminated by the blinding blue flash of arc welders and naked electric bulbs strung from tree branches. The equipment they brought ashore was staggering. 10-ton heavy wreckers equipped with A-frame booms acted as the cranes. Standard cargo trucks were fitted out as rolling machine shops, containing metal lathes, drill presses, and air compressors. If a Sherman needed a completely new engine, the heavy mechanics did not try to fix the shattered block. With overhead gantries, could tear the vehicle down to its bare chassis. When a machine died in the mud, it stayed dead until heavy industry. They backed a wrecker up to the rear deck, attached the hoist, and physically ripped the destroyed engine out of the hull. Within hours, a fresh power plant, brought up from a rear supply dump, was lowered into the empty bay and bolted down. They performed structural metalwork that European doctrine insisted could only happen in a civilian factory. If a German anti-tank shell had punched a clean hole through a turret, the ordnance welders simply cut away the jagged edges with oxyacetylene torches. They would then take a slab of raw steel, or often a piece of armor cut from a destroyed German tank, and weld it directly over the penetration. The resulting scar was ugly, thick, and highly visible, but it restored the structural integrity of the crew compartment. These heavy maintenance companies operated under a time limit measured in days, not hours. If a repair took between a few days and a week, it belonged to them. They swapped bent gun barrels, replaced ruined transmissions, and hammered out warped suspension bogies. And because this entire industrial apparatus was mounted on tires, it could pack up and move forward with the advancing army, ensuring the repair yard was never more than a short tow away from the fighting. This was how the dead Sherman from the Normandy crossroads was returned to the fight. A heavy wrecker pulled it to a field. An ordnance crew swapped the shattered drive sprocket, intervened. Because the Americans were fighting an ocean away from their own manufacturing centers in Detroit, the German crew had every reason to believe, welded a steel plate over the shell hole, and sent it rolling back to the front line before the week was over. But even these muddy workshops had a strict threshold. Sometimes a tank suffered catastrophic trauma. A direct hit from an 88mm gun could warp the entire chassis, or an internal ammunition fire could burn so hot that the armor lost its temper. When a vehicle crossed the line from severely damaged to completely destroyed, it could not be fixed. To understand what happened to those total losses, we have to look at the brutal calculus of the fifth echelon and how the Americans turned a dead tank into a logistical weapon. Not every casualty dragged into the muddy clearings of the fourth echelon could be resurrected. There was a physical limit to what the mobile machine shops could achieve. If a Sherman took a direct hit to the ammunition stowage, the resulting internal fire would burn so intensely that the armor plating itself lost its metallurgical temper, becoming brittle and structurally useless. If a heavy solid shot round struck the massive steel casting of the final drive, it could twist the entire 30-ton chassis permanently out of alignment. When the senior ordnance officers examined a wreck and determined it would take weeks to repair, or that it was structurally dead, they did not order it. This specific Sherman was erased from the campaign forever. 72 hours later, the German position came under a renewed assault. The gunner settled behind, to be buried or abandoned. They initiated the brutal, unsentimental process of the fifth echelon. The vehicle was officially written off the armored division's ledger as a total loss. But in the physical reality of the battlefield, a dead tank was not a liability. It was an organ donor. This was the pure logistical logic of cannibalization. The American military realized that a catastrophic hit rarely destroyed a machine completely. A Sherman with a Postoren, gutted crew compartment, and a warped front glacis might still hold a pristine engine block sitting in the rear deck. Its turret might be shattered, but the heavy steel road wheels, the suspension bogies, the internal radios, and the main gun tube might be completely untouched. Instead of waiting weeks for a cargo ship to cross the Atlantic with a crate of specific spare parts, the mechanics stripped the dead tank down to its bare skeleton. Working with heavy oxyacetylene cutting torches, air-driven impact wrenches, and steel crowbars, they harvested everything usable. A transmission assembly was unbolted, hoisted out, and immediately lowered into a different tank waiting nearby. Intact track links were pounded loose with sledgehammers and stacked in the backs of cargo trucks. Gun sights, carburetors, alternators, and even the undamaged seat cushions were stripped, categorized, and added to the mobile inventory. By sacrificing one destroyed vehicle, the maintenance companies suddenly possessed the exact components required to repair 3 others. The stripped hull was then shoved into a ditch, the site of the PaK-40, scanning the tree line as an armored column emerged from the mist. The lead tank stopped, its turret rotating, or left in a designated salvage park, a hollow, rusting carcass stripped of every valuable bolt and bracket. To the German High Command, intercepting an American report of a tank being formally written off suggested a permanent strategic depletion of enemy armor. They did not understand that the death of one American tank directly accelerated the resurrection of several others in the exact same sector. The fifth echelon ensured that the transatlantic pipeline never truly ran dry because the battlefield itself became the primary parts depot. The echeloned maintenance system was an undeniable masterpiece of industrial triage. By sorting mechanical casualties strictly by repair time and relentlessly harvesting the dead to heal the wounded, The American Army maintained a staggering operational readiness rate. But this entire invisible factory relied on one crucial assumption. It required the luxury of geography. The mobile workshops, the 10-ton heavy wreckers, and the stockpiles of salvaged engines needed a secure rear area to function. The system looked mathematically perfect as long as the Allied lines were advancing and the ground was safe. The true question was whether this complex time-based triage could survive a sudden, violent retreat where the mud of the repair yard suddenly became the front line. In the freezing dawn of the 16th of December 1944, the luxury of safe geography completely vanished. The German army launched a massive surprise counteroffensive through the Ardennes forest toward the anti-tank position. Through the glass, the gunner saw something that openly defied the mechanical laws of the war. It was an M4 Sherman shattering the American front lines. Within hours, the deep rear areas where the 3rd and 4th echelons operated were no longer secure. Ordnance mechanics, who had gone to sleep thinking they were 15 miles behind the fighting, woke up to the sound of incoming mortar shells and the distinctive grind of enemy tank treads. The physical space required to run a mobile factory had suddenly collapsed. The echeloned maintenance system was fundamentally designed for an advancing army. It required stable supply routes, predictable perimeters, and the safety of time. Now, heavy maintenance companies found themselves working in knee-deep snow, their bare hands sticking to frozen steel wrenches while German infantry advanced through the surrounding tree lines. If the system had been merely a bureaucratic luxury, it would have disintegrated under the shock. Instead, the triage protocol instantly adapted to the crisis. The standard calculation of time to repair was replaced by a brutal binary metric. Could the machine roll? Could it be towed? Or did it have to die? The muddy workshops transformed into scenes of frantic, heavily armed triage. Mechanics scrambled over the hulls of partially disassembled Shermans. If an engine swap was only half finished, they did not abandon the vehicle. 10-ton heavy wreckers roared to life, their tires slipping on the icy roads, hooking thick steel tow cables to the crippled tanks. But it was not a fresh replacement vehicle brought up from the invasion beaches. On the lower right side of the hull, exactly where the sight, welders and machinists suddenly found themselves holding M1 rifles to defend the perimeter while their units dragged 30-ton casualties backward through the snow, often under direct artillery fire. The ordnance companies packed their metal lathes, cutting torches and air compressors into cargo trucks in a matter of minutes. The factory on tires simply put itself in gear and drove away. Not every damaged vehicle could be saved. If a tank was completely immobile, too deeply mired in the freezing mud to drag, or trapped by the collapsing front, the mechanics executed a rapid, localized version of the 5th echelon. They did not leave a usable weapon for the advancing enemy. Ordnance crews dropped thermite grenades down the breeches of the main guns, permanently melting the firing mechanisms into useless slag. They smashed radios with sledgehammers, drained the engine oil, and ran the motors until they seized into solid blocks of ruined metal. They saved the specialized hand tools, abandoned the stripped steel, and fled. The true proof of the system was not how it retreated, but what happened immediately after. Once the surviving cargo trucks and wreckers reached the new defensive perimeters around crossroads, towns like Bastogne, they did not wait for strategic directives. They pulled off the road into new snow-covered fields, strung up the camouflage netting. Armor-piercing shell had struck 3 days earlier, sat a jagged, freshly ground weld scar. The right track was fully tensioned and rolling smoothly. The shattered and restarted the diesel generators. The mechanics picked up their heavy tools and resumed swapping tracks and hammering out suspension bogies in sub-zero weather. The invisible assembly line had been violently pushed backward, but its machinery never stopped running. The American maintenance network survived the shock because its core components were entirely mobile. But as the fighting raged across the Ardennes, a stark contrast began to emerge in the frozen landscape. The opposing army, advancing through the exact same weather and over the exact same roads, was slowly grinding to a halt. The German forces had captured the ground and broken the American lines, but they could not keep their own armor moving. To understand why, we have to look at the mechanical reality of the enemy and why they could not simply copy the system they were fighting against. As the German spearheads pushed deeper into the Ardennes, their momentum began to suffocate under their own mechanical weight. The winter offensive stalled not just from American resistance, but from an accumulation of shattered transmissions, thrown tracks, and frozen engines. The German forces possessed highly skilled mechanics and heavy prime movers. They could see the American repair network adapting to the chaotic retreat, resurrecting Shermans in snow-covered fields. Yet the Wehrmacht could not simply copy this forward repair triage. The barrier was not a lack of tactical imagination. The answer lay in the machines themselves. Drive sprocket was gone, replaced by a brand new assembly bolted securely in place. The tank that had been left smoking and gutted in a ditch. The American Echelon system functioned efficiently because the Sherman tank was designed from its inception to be repaired in the mud. The German heavy armor, the Tigers and Panthers leading the winter offensive, were engineered for supreme battlefield dominance, but they achieved this at the fatal cost of maintainability. Consider a simple transmission failure. If a Sherman stripped its gears, an American ordnance crew could unbolt the massive front steel housing, attach a wrecker boom, and pull the broken transmission directly forward. They could slide a new assembly into place without disturbing the rest of the vehicle. If a German Panther suffered the exact same mechanical failure, the field mechanics faced an engineering nightmare. The Panther's transmission was buried deep beneath the front hull roof. To extract it, mechanics often had to use heavy lifting gantries to completely remove the tank's massive turret first. What took an American crew hours with a tow truck took a German crew days with specialized factory equipment they did not have in the frozen forest. The suspension systems offered an even harsher contrast. A Sherman rode on modular external bogies bolted to the flat side of the hull. A mechanic shivering in a trench could unbolt a ruined wheel and swap it using basic jacks and a heavy wrench in less than an hour. The German Panther and Tiger utilized an interleaved road wheel system, a complex, overlapping arrangement designed to distribute the vehicle's massive weight and provide a stable firing platform. When an American armored column finally edged into the intersection, the gunner centered his optics on the lead M4 Sherman and pulled the lanyard. Was now moving under its own power, firing its main gun. To the men behind the anti-tank position, this was a mathematical impossibility, a structural, but if a single inner wheel was damaged by a mine, or if the mud packed between the wheels froze solid overnight, a German crew had to remove 5 or 6 outer wheels just to reach the single broken one. This mechanical complexity was compounded by a severe lack of standardization. An American mechanic pulling an alternator or a starter motor out of a wrecked Sherman in one ditch knew it would perfectly fit a wounded Sherman 3 miles away. The German industrial base, scattered and constantly under aerial bombardment, produced a steady stream of bespoke variants and minor factory upgrades. A mechanical component for an early production Panther often would not fit a later model. This severely limited the logic of cannibalization. A disabled German tank was often useless as an organ donor, its specific parts incompatible with the vehicles parked right next to it. The German army was trapped by its own engineering culture. They had built formidable weapons that inherently required deep rear factory conditions to repair, and in the freezing forests of Belgium, the factories were hundreds of miles away. As the winter offensive ground to a halt, the roads littered with abandoned, highly advanced machines waiting for trains that would never arrive. The true nature of the American victory began to materialize. The deciding factor of the armored war was not the thickness of the frontal steel. Mobility kill could not be undone with hand tools in a muddy field. There was no American heavy industry in Normandy, and no rail networks, or the muzzle velocity of the main gun. The war of attrition was being won by an invisible system. To find the final verdict, we must look past the weapons themselves and return to the muddy crossroad where the illusion of the immortal tank first began. When the German gunner in the Normandy hedgerows peered through his optics in the summer of 1944 and saw the resurrected Sherman roll back into the crosshairs, he was not looking at a mechanical miracle. He was looking at a profound failure of his own military doctrine to understand the enemy. The gunner believed he had erased away. He saw the shattered drive sprocket and the smoking engine grille, and he calculated the weeks of rail transit and heavy factory labor required to restore it. Because the Americans had no heavy industry in France, and absolutely no way to ship twisted wreckage back across the Atlantic Ocean, he assumed the machine had to be permanently dead. The question was never really about the thickness of American armor, the muzzle velocity of their guns, or the supposed immortality of the Sherman tank. It was about the relentless, unglamorous management of time. The German military designed masterpieces of engineering that inherently demanded the sterile environment of a deep rear civilian factory, were shipping wounded tanks back to Michigan. Yet, the dead machine had been resurrected and returned to the exact same sector in less time than. The United States military accepted that a tank was merely a temporary, interchangeable container for parts, and designed a triage network that treated time as the ultimate battlefield weapon. The opposing gunner could clearly see the thick, jagged weld scar on the side of the Sherman, but he could not see the invisible chain of human labor that put it there. He could not see the first echelon crews wrestling heavy steel track pins in the freezing rain. He could not see the second echelon mechanics working out of half tracks in the pitch black, swapping broken carburetors entirely, by touch so a flashlight would not attract enemy mortars. He was completely blind to the 10-ton heavy wreckers dragging 30-ton casualties through the mud, and the brilliant blue flash of arc welders operating beneath the camouflage netting of the third and fourth echelons. And he could never comprehend the ruthless logic of the fifth echelon, where dead tanks were violently cannibalized down to the bare metal, to ensure the transatlantic pipeline never ran dry. The United States fought a massive mechanized war thousands of miles away from its own arsenals, and it never sent a single disabled tank back home for repair. Instead, it militarized the assembly line. It would take a German tank just to reach a local railhead. The enemy could clearly see the consequence of this resurrection, but they were, by instantly separating the quick fixes from the depot-level rebuilds right at the edge of the fighting. The triage protocol ensured that a shattered periscope never delayed the replacement of a ruined engine block. But a system is ultimately just a concept printed in a field manual. What made the echeloned maintenance network real was the immense physical toll extracted from the men who operated it. The ledger of time was balanced by soldiers in oil-soaked coveralls, working in knee-deep mud and sub-zero snow. It was made real by the mechanics, the welders, the wrecker drivers, the radio technicians, and the machinist mates who operated heavy metal lathes while the ground literally shook from artillery fire. They were men who often worked until they collapsed from exhaustion, holding a heavy wrench in one hand and an M1 rifle in the other. When that Sherman returned to the fighting line, firing its main gun, it was not an unstoppable monster. It was the end product of a massive, mobile factory that simply refused to let the steel die. The ugly, unpainted weld scar on its hull was not a vulnerability. It was the physical signature of the men who kept the iron moving forward, entirely blind to the machinery producing it. What looked like a miracle through a gun sight was actually the output of a massive, invisible assembly line operating directly behind the fighting lines. But to understand how the Americans achieved this impossible battlefield turnaround, we first need to look at why the European armies believed it could not be done at all. To understand the confidence of the German gunner, you have to look at the anatomy of a battlefield recovery in 1944 Europe, when a German medium tank suffered catastrophic damage, a pierced engine block, a bent chassis, or a shattered drive assembly. It triggered a massive, slow-moving logistical chain. First came the recovery phase. A heavy prime mover, often an 18-ton half-track. The metallic crack of the 7.5mm gun shattered the damp morning air. A second later, a solid armor-piercing shell, slammed into the lower hull, would arrive under the cover of darkness. Cables as thick as a man's wrist were hooked to the dead tank's towing eyes. With the mud sucking at the road wheels and the engines screaming under the load, the crippled machine was dragged miles away, from the artillery zone to a local collection point. That was only the beginning of the journey. The field mechanics in the German army were highly skilled, but they operated under a strict doctrinal ceiling. They could replace a broken track link or swap a fouled carburetor. They were not equipped, nor expected, to rebuild a pulverized hull, weld structural steel, or remachine a shattered turret ring under the trees. For that level of trauma, the tank had to go home. It would be winched onto a reinforced flatbed railcar. From the depots in France, the wounded machine began a journey of hundreds of miles back into the industrial heart of the Reich. It would eventually roll into a massive facility in Kassel or Nuremberg, passing under high steel gantries. Here, in a dry, well-lit factory, civilian engineers and heavy electric cranes would lift the turret, extract the ruined engine, and cut away the torn armor. The tank was rebuilt from the inside out, repainted, and finally loaded onto another train of the American tank. The Sherman violently lurched sideways. Its heavy steel track snapped, unspooling into the mud like a broken watch spring, to return to the front. This was the standard European doctrine of heavy repair. It was thorough, but it was incredibly slow. A tank that took an anti-tank round in July might not see combat again until September, assuming the rail networks were not severed by Allied bombers. When the German crew in Normandy watched the American crew abandon their shattered Sherman, their math was entirely correct according to their own system. The tank was structurally compromised. It required heavy industry. It was erased from the immediate summer campaign. The blind spot in this calculation was geography. The Wehrmacht was fighting on its own continent. The United States was fighting across the Atlantic Ocean. For the American forces pushing through the French hedgerows, the assembly lines of Detroit and the arsenals of Ohio might as well have been on the moon. A Sherman tank loaded onto a Liberty ship in New York was taking a one-way trip. The logistics of transatlantic supply dictated brutal rules. Shipping a fresh replacement tank took weeks of coordination and consumed massive cargo space. Shipping a shattered, oil-soaked wreck back to the United States against the flow of incoming ammunition, fuel, and fresh troops was completely out of the question. The right drive sprocket was completely shattered by the kinetic impact, and thick white smoke immediately began venting from the engine grills. The crew hatches. The American military could not crate up a violently disabled vehicle and mail it back to Michigan. The traditional European solution of the deep rear factory was physically unavailable to them, but this limitation created a devastating operational problem. In a war of severe attrition, an army that abandons every heavily crippled vehicle will run out of armor long before it reaches the enemy capital. If the Americans could not send their wreckage back to the industrial heartland, they had to find another answer, in the mud of the battle zone. To understand how they solved this, we must first look at the massive logistical barrier that forced their hand. The Atlantic Ocean was the most ruthless quartermaster of the Second World War. Every piece of equipment the United States military deployed in Europe, from a half-ounce rifle cartridge to a 30-ton medium tank, had to cross 3,000 miles of cold, contested water. Loading a Sherman tank onto a Liberty ship at a pier in New York required heavy dockyard cranes and careful weight distribution. Once that ship crossed the ocean and the tank rolled down a steel ramp onto a French beach, its physical ties to the American industrial heartland were permanently severed. The logistical pipeline was a strictly one-way valve, flowing relentlessly eastward, flew open, and 5 American tankers scrambled out into the nearest ditch. Through the magnified glass of his gun sight, the German gunner observed, the cargo ships returning to the United States were carrying wounded soldiers, empty fuel drums, and German prisoners. There was no deck space available for 30 tons of twisted, grease-soaked steel, and no port commander was going to waste precious loading hours winching a dead tank into a cargo hold. The ocean acted as an absolute filter. If a piece of armor crossed the Atlantic, it was staying in Europe forever. This created an unprecedented mathematical crisis for American planners. The standard European model of attrition assumed a steady recycling of damaged armor through deep rear factories. German and Soviet tanks were routinely shipped back to the cities where they were built. But if the Americans simply abandoned every tank that suffered heavy mechanical trauma, such as a warped chassis, a turret jammed by a high-explosive strike, or a transmission ground to metal shavings, the Atlantic shipping lanes could never deliver fresh replacements fast enough to sustain the offensive. A tank left to rust in a ditch was not just a lost weapon, it was a total waste of the immense shipping tonnage and fuel required to bring it there in the first place. The solution demanded a complete reversal of traditional military logic. If the broken metal could not travel back to Detroit, then Detroit had to travel to the broken metal. The United States Army Ordnance Department, a permanent victory. The crew was gone, and the vehicle was completely mobility killed. By the prevailing logic of the European battlefield, a 30-ton machine realized they could no longer treat heavy vehicle maintenance as a stationary, civilian-run process. They had to militarize the assembly line itself. This meant packing the capabilities of a heavy industrial factory into trucks and trailers. It meant tearing down the walls of the machine shop and putting it on tires. Oxyacetylene torches, metal lathes, air compressors, and 10-ton heavy wreckers were mobilized and shipped across the same ocean. The Army took thousands of civilian mechanics, certified welders, and precision machinists, put them in olive-drab uniforms, and deployed them to work under camouflage netting within earshot of enemy artillery. But recognizing the geographical constraint of the ocean was only the first step in solving the problem. The sheer volume of mechanical casualties generated by an advancing armored division threatened to overwhelm any mobile field workshop. If every broken fan belt, thrown track link, and shattered drive sprocket was sent to the exact same mechanics, the entire repair network would instantly paralyze itself under a mountain of broken parts. To prevent a minor breakdown from causing a massive traffic jam of wounded steel, the American military needed a way to instantly separate a quick fix from a major rebuild right at the edge of the fighting. To understand how they achieved this, we have to look at the invisible triage network they built. With a destroyed drive assembly and structural hull damage was no longer a weapon. It was simply 30 tons of scrap metal blocking a narrow tons privest, and the specific unit of measurement they used to decide a vehicle's fate before the engine even cooled. When the smoke cleared over a French intersection and an American Sherman sat immobilized, the first diagnostic question asked by the surviving crew was not how badly the tank was broken. The question was how many hours it would take to fix. This single shift in perspective was the foundation of the echeloned maintenance system. It was a rigid, unsentimental triage protocol based entirely on the clock. The United States military understood that if every broken machine was sent to the same repair yard, the backlog would instantly paralyze the armored division. To survive the attrition of Western Europe, they had to filter the damage before the vehicle ever left the battlefield. The filter consisted of 5 distinct echelons. The first 2 operated under the constant threat of incoming fire, acting as a dam to keep minor damage from overwhelming the system. The first echelon was the tank crew itself. If a Sherman threw a track in the mud, or a fan belt snapped, or a machine gun jammed, the tank was not officially considered a casualty. The driver and assistant driver pulled out a standard canvas tool roll. Using heavy sledgehammers and steel crowbars, they knocked out broken track pins and wrestled the steel treads back onto the drive sprockets. If the repair could be measured in minutes, dirt road. The German commander tallied the kill in his logbook. He understood the mechanical rules of the war. A tank crippled to this degree, it belonged to the crew. The vehicle never left the platoon, but if the damage exceeded the crew's tools, the vehicle was handed to the second echelon. These were the company and battalion level mechanics. They did not wait safely in a rear area garage. They followed the fighting tanks directly into the field, usually operating out of an M3 half-track loaded with heavy jacks, spare road wheels, carburetors, and a small arsenal of wrenches. If a Sherman took a glancing hit that shattered a bogie suspension unit or a mortar fragment pierced the radiator, the company mechanics rushed in. They worked in the mud, often under the cover of smoke or darkness. Their limit was strictly dictated by time and lift capacity. They were authorized to perform repairs that took hours, not days. They could swap a damaged radio, replace a severed fuel line, or change out a cracked road wheel using hand tools. This time-based triage was incredibly efficient. By filtering out the quick fixes, the first 2 echelons ensured that nearly 3/4 of all mechanical problems were solved directly behind the fighting line. A tank with a shattered periscope never competed for a mechanic's attention with a tank that had a ruined engine. But this forward system only worked because the mechanics knew exactly when to walk away. If the damage crossed a specific threshold of time and trauma, the rules changed. If a German solid-shot shell had sheared the turret ring,